So for A2 chemistry, we just look at alpha amino acids. Now amino acids, let's have a look at the name. What groups are they going to contain? Amino.
NH3.
Amine group, yes, NH2. And a carboxylic acid. So they all have this structure. I've got a carbon atom. I then have a carboxylic acid group coming off that carbon. I then have an amine group coming off the other one, and then I have an H. The thing that varies for all the different types of amino acid is this group here. This can be a different thing. And this could just be a carbon chain, it could be a hydrogen, it could be another carbon chain with a benzene ring coming off of it. These are all called alpha amino acids. And the reason they're called alpha is because both the amine and the carboxylic acid come off the same carbon. So, the simplest example of an alpha amino acid is this one. This one would be called glycine. The next easiest example would be this one, where you have a CH3 group coming off of it, and that would be called aniline. So, and those are their, obviously not their proper systematic names of engineering. You don't have to learn all the amino acids, you'll be pleased to know, but you do need to know the general formula for amino acids. So they may say, well, what is an alpha amino acid? That's what you do, where the R group can vary depending on the specific amino acid. Now, well, let's have a look. This, I've got an acid group. So that's acid. This has acidic properties. And this we know has got basic properties. Why can that act as a base? Yeah, because it's got a lone pair on the nitrogen atom, and this guy. So, generally, they exist in this form. So they exist as a Zwitterion, okay, which means it has already undergone an internal acid-base reaction, whereas that H has popped off and gone over to the nitrogen there. So generally, they exist in this form, where the hydrogen has popped off of there and gone on to that nitrogen there. And that is known as the Zwitterion. And the pH at which they exist at that is called the isoelectric point. The arrow is just showing that hydrogen, that's what they do. They do an internal acid-base reaction. So the H, they kind of get together, each end of the molecule says, yo, I've got hydrogen, why don't you pop over to this side?
Is that a double bond?
This is a double bond, yeah. So that has lost the hydrogen and that's gone. And each amino acid has a different isoelectric point. So, but you'll be given that information, but if it's at the isoelectric point exists at this time. So, if I was to buy an amino acid, I go and buy an alpha amino acid, what state do you reckon it will be in? Will it be a solid, a liquid, or a gas? If you look at the molecular structure, yeah, you kind of think, yeah, okay, got a bit. What type? If I draw two of these Zwitterions together, what type of intermolecular attraction will be between that guy and
hydrogen.
this guy? What's that? I got a minus there, a full minus, and I got a full plus. It is ionic, yeah. So you've got strong attraction, so these would come as solids. Yeah. So if I can take my basic glycine state, and I'm just going to draw it as normal, like so. At this isoelectric point, which is, it's around, between 6 and 8 pH. And it's isoelectric point, it would exist as the Zwitterion. And I've done my internal acid-base reaction. That's the plus. That's HH, minus. But let's say now I take this guy and I react it with an acid. So I'm going to react it with HCl. So this is going to be at low pH. I have bombarded it with H plus ions. How will the structure change? Will that bit change at all? No, it's already fully, I can't get any more hydrogen than that. What about this?
Another hydrogen?
Yeah, cool. So, he can act as a base, so I will end up with that being plus, because he's just acted like a bog standard amine that we've just done. If they then said it's HCl, I'm going to put a Cl minus ion there as well. So again, I've got a salt. If I did it at a high pH, so I stick it in sodium hydroxide solution, so at high pH, what's going to happen to that? What change will sodium hydroxide now? Thinking about carboxylic acid chemistry. Yeah, it's going to react with this guy here. It won't be no, it should be an acid-base reaction.
Okay.
So that's going to go O minus, and if it was sodium hydroxide, I'd also have the Na plus there. So if we just look at the amino acids, at a low pH, they have a positive charge, and at a high pH, they have a negative charge.
Do you have to